Okay, the line L is tangent to the circle x squared plus y squared equals 40 at the point A. A is 2, 6. L crosses the x-axis at P. Work out the area of OAP. Right, so firstly, we've got a circle x squared plus y squared equals 40. Let's sketch that. Okay, so, God, these pens make a racket. We have a circle. Ah, what a noise! Ah! Okay, there's our circle. X squared plus y squared equals 40. Right, that's the general equation of a circle, okay? X squared plus y squared equals r squared. General equation of a circle. R is the radius of the circle, so r squared is 40. So the radius of this circle, okay, is root 40. Okay? The reason is, at any point on the circle, you've got the point x and y, okay? That's a right angle. You can see that that's y there, and that's x there, these distances. It's a right angle triangle, so it's Pythag. The hypotenuse, which is the radius of the circle, is the sum of the squares of the opposite two sides. So r squared is x squared plus y squared. So therefore that's r squared. X plus y squared is r squared. Anyway, the radius of this circle is root 40. Okay? Now, the point A, they tell us A, it's a point 2, 6. So at some point, 2, 6, doesn't really matter where we don't have to get it super accurate. It's the concepts that matter. So we've got this point here, which is x is 2 and y is 6, okay? L is tangent at this point A. So there's A. Tangent means it's a straight line doing something like that, okay? So we have our tangent line here at the point A, tangent to the circle. What else? L is the tangent, so that's L, that line is L. And L crosses the x-axis at the point P, so that's P. Okay? You see, we're building it up. Work out the area of triangle OAP. Well, O is the origin there. Okay? So O to A, well, that's root 40. It's the radius of the circle. Okay? So we know O to A. O to A to P, there's our triangle. We need the area of this triangle. Okay? So, O to A is root 40, radius of the circle. If we treat O to P as the base of the triangle, then the height is from there to there, which we know is 6. So that's 6, okay? Now, the formula, the general formula for the area of a triangle is half times base times height, okay? So like I say, if we treat O to P as the base, then we know the height is 6. So we can work out the area. We just need to know the base. In other words, we need to know where L crosses the x-axis. If we knew that, we would know the base and we'd have the area. So, how do we work out where L crosses the x-axis? What we do is work out the equation of the line L and then set y equal to 0, because at y equals 0, that's the point where it crosses the x-axis. Okay? So, how do we work out the equation for the line L? Well, we know it goes through this point here, which is 2, 6. So that's a very good start. If you know a line goes to a certain point all you need, the only other thing you need to work out is the gradient of that line, and then you've got the equation. So how do we work out the gradient of L? Well, it's tangent to this circle, which means that is a right angle, okay? So if we know the gradient of this line, because they're at right angles, we can immediately work out the gradient of L. And we can work out the gradient of this line because it's just rise over run, 6 over 2. So that's our route to the answer, okay? So let's do it. We're going to start off by working out the gradient of this line here. Now, what should we call it? Let's call it, M is usually used for gradient. We're going to call it M1. Okay? Now, M1 is just rise over run. Okay, which is from 0, 0, it goes from 0 to 6, so the rise is 6, and the run is from 0 to 2, which is just 2. So the gradient of that line there is 3. Okay? Now, I promised you we could immediately work out the gradient of this line if we knew that, because they're at right angles. And we do that by taking the negative inverse of this. Okay? If two lines cross each other at right angles, the gradient of one is always the negative inverse of the gradient of the other. Remember that, okay? So, the gradient of L, let's call it M2, okay? We can immediately write down it's a negative inverse of 3, in other words, minus 1 over 3, okay? Remember that. If two lines are perpendicular, negative inverse of one gives you the gradient of the other. And one gradient gives you the other gradient, okay? So, we know L goes through 2, 6, and we know it's got gradient a third. So we've got enough information to get the equation of the line. So let's do that. So the equation of L, we can use this form, y equals mx plus c. Okay, that is a perfectly respectable equation of a straight line. But I'm going to use the other version, okay, which is this. Y minus y1 is m times x minus x1, okay? I'm going to use, these are the same equation, okay, just in different form. I'm using this one because the point x1, y1 is any point on the line. And I'm using that version because we have a point. We know it goes to the point 2, 6, okay? So x1 is going to be 2 and y1 is going to be 6 in this equation, okay? Learn both of these. Like I say, they're two different versions of the same equation, the equation of a straight line. But when you know the line goes to a certain point, it's more convenient to use this one. So our point, like I say, is 2, 6. So x1 is 2, y1 is 6. So therefore, y minus y1, which is 6, is equal to m2 in this case, minus a third. The gradient is minus a third. X minus x1 is 2. Okay? Right, brilliant, we've got it. There's the equation of L. We can neaten it up a bit. So y minus 6, I've had enough of this pen. It's killing my ears. Let's try this one. Ah, it's better. Bliss. Okay. Minus a third times x is minus a third x. Minus a third times minus 2 is plus 2 thirds. Okay, add 6 to both sides. Y equals minus a third x plus 6 and 2 thirds. That's fine. We'll leave it like that for the moment. So there's our equation of L. Right. Now, we're interested in where L crosses the x-axis. We want that value of x right there, because that will give us our base of our triangle. So it crosses, this line crosses the x-axis when y is 0. Okay, so we just set y equals 0. So 0 equals minus a third x plus 6 2/3. Okay. Okay, 0 equals minus a third x. I'm going to make that top heavy. 3 times 6 is 18 plus 2 is 20. Okay, multiply everything by 3. 0 times 3 is 0 equals minus x plus 20. Okay, therefore x is 20. Yeah. Because minus 20 plus 20 is 0, so x is 20. Good. So at that point, x is 20. And because our triangle starts at 0, the base of our triangle is 20. So we've done it. So we've reduced the problem to this. Ah, this pen started now. Oh, God. Right. The height of our triangle, that's O, that's A, and that's P. The height is 6. Okay, h equals 6. The base is 20. So simple. Area of our triangle is half times the base, which is 20, times the height, which is 6. Half of 20 is 10. 10 times 6 is 60. There we go. What are the units? I can't remember. Doesn't matter. It's all the maths that matters. The answer is 60, whatever the units are. There you go. That's how it's done. Good question. Quite a lot in that. Formula for the area of a circle. Knowing that two lines at right angles have the negative inverse gradients. Setting y equals to 0 to find the x value where it crosses the x-axis. Knowing these equations for the equation of a straight line. Yeah, good. Anyway, there you go. That's how it's done.